Hello there, math enthusiasts and all around adventurers, all awesome people. Welcome to my YouTube channel. I'm Mr. Le Cordeur. Today we are here at Mnr High School, a very historic school. It is one of the oldest schools in the beautiful city of, or the town of Paul. So today we're looking at the topic of grade 9 mathematics. We will be looking at exponents. All right, so join me on this journey as we walk through the basic laws. Yesterday we looked at the first law, which says if my exponents or if my bases are the same, what can I do with my exponents grade 9? I can add my exponents. If my um, bases are the same and I'm doing division, what can I do with my I can subtract my exponents, all right? And then we also did law number 3 was the power to power rule, which means when I have a power with inside a bracket and I have a power outside of the bracket, I can multiply the two powers with each other. All right, today we're moving on to law number 4 and we have some questions there. All right. So, guys, you have already copied the following into your workbook. We're just going to re-emphasize. We're starting, I think, there, number 1.10. All right. So some of us already started with this. So 1.10 says there we have, and there's many ways how you could have done this. There's 2 times 5 to the power of 2. All right. Now going by the law, it says they apply law 4, and I think this is the law of distribution. Now because there is a multiplication, Bod must actually advise us that we can simplify the brackets first. So I'm going to do it on that way. So if I multiply 2 times 5, my answer is going to be 10. And 10 to the power of 2 is then 10 times 10, which means 100. There's another way how I could have done this. I could have said, okay, but if I use the law of distribution on the first one, then I can say it's actually going to be 2 to the power of 2 times 5 to the power of 2. Both of them gets a 2 there. And I know that 2 to the power of 2 is actually 4. And that's 4 times 25. Now, if I have 25 fingers on the one hand and another 25, that makes 50. Now, if you have 25 fingers as well, that's 75. And another 25 is also 100. So the same answer on different methods. Do you see there? Okay. Moving on to the next one, we have the 1.11. 1.11, I think there it looks like we have 3 to the power, sorry, it's in the bracket 3x to the power of, bracket closed, to the power of 3. Alright, now remember distributing, learners. You need to distribute with this one as well as with that one. That's 3 to the power of 3 and x to the power of 3. This is actually 1 times 3, which equals to 3. And that one is 3 times 3. 3 times 3 is equals to 9. So that becomes 3 times 3. Sorry, that's not 3 times 3. It's 3 to the power of 3. Because 3 times, so that means 3 times with himself. How many times? 3 times. So that's actually 327x to the power of 9. And I know everyone in this class probably got that one right. We're just marking our work and checking that we have the right stuff. All right, number 1.12 there. Number 1.12 looks like this. We have the bracket negative 4a. What is that to the power of? 5. And then we have b to the power of? Is it 3? All right, we close the bracket and then we have 2 outside of the bracket. All right, so in essence, what this actually means is this bracket is multiplied and everything within the bracket is multiplied with itself twice. All right, so that applies with this negative as well. Now, what is a negative times a negative? A positive. So I know my answer is going to be positive. All right, now I need to distribute 4 to the power of 2. I can write it down as is, and then I'm going to say, because there's actually 8 times with, that's 4 to the power of 1 times with 2 there. Then we have 5 times 2, and then b to the power of 3 times 2. All right, now this step, you don't actually have to write it down. You can go straight to your answer, but I'm writing you down so that you can see where the answer comes from. So 4 to the power of 2, that means 4 times 4, which is not 8, but 16. All right, so 16a. Then we have a 5 times 2 is equals to a to the power of 10. And then b to the power of 6. It's positive, your answer, final answer right there. Moving on, grade 9 learners, we are do this at number 1.13. So number 1.13 looks like this. We have the 5 to the power of 0. Now the exponent there, the base is 5, the exponent is 0. So my answer is simply just 1. All right, now we're moving on there to number 1.14, and then we have 7 times with a to the power of 0. Now careful for this one. The 7 has an exponent of 1. So it's actually 7 times with 1. And 7 times with 1 is just 7. So your answer there is 7. Then at number 1.15. Number 1.15, we have there 3p to the power of 0 plus bracket 3p to the power of 0. Bracket closed. All right. What this means, once again, look out for these ones. The 3 has an exponent of 1. So that's 3 times 1, which equals to 3. Then this whole thing is actually 1. So that's 3 plus 1, which equals to 4. And that's my answer there for that one. Can see the smiles there that everyone has this correct. No? So great stuff there, grade 9. Moving on now. Why is this so? If we go, yesterday I showed you how we can do this, all of these laws that we have, and we can do the simplification without the laws. But that, in essence, takes us a lot of time, and we're actually complicating stuff for us. But let's go quickly and look at the law. Why is this law so? Why is anything to the power of 0 equals to 1? Because that is the law, what it says. Anything to the power of 0 is equals to 1. Let's take, for example, 2 to the power of 3. No? And I'm going to divide that by 2 to the power of 3. So what I'm saying, I'm doing law number 2 now. My bases are the same. So, and I'm doing what is a fraction? I said the fraction is actually division. And if my bases are the same and I'm doing division, what can I do with my exponents? Subtract my exponents. So this is the short way now by using law 3, and then we get 2 to the power of 0, which equals to 1. But now I'm going to do it without the laws that I know. So I'm going to say 2 to the power of 3. So that means 2 times 2 times 2 over 2 times 2 times 2. So all of this basically cancels out. How many times does all of this go into that? Only once. And that is the reason why anything to the power of 0 is equals to 1. Yes. Maura. Right. Yeah, you go. Moving on there, we're going now to the next law. And now we have the law says that we don't want to work with negative exponents. All right. So we convert when we have a number like this. The rules look like this. We have a to the power of negative 1. We're going to write this as 1 over a. Okay. Looking at that, we have there, that's 2, number 1.16 is then 2 to the power of negative 3. All right, stay with me, grade 9 learners, stay with me. So I want to first convert this from a negative exponent to a positive. So that's going to be 1 over 2 to the power of 3. But I know that 2 to the power of 3 basically means 2 times 2 times 2. 3 times. 2 multiplied with himself, 3 times. Hold on, I'm just gonna finish that. 1.17, it's x to the power of negative 4, right? What is that gonna become? 1 over x to the power of 4. Then we are going to have number 1.18 is, what is that? A to the power of 3 multiplied by b to the power of negative 4. Now note that this exponent here is positive, but this one is negative. So in essence, actually a to the power of 3 times with 1 over b to the power of 4. Alright, so this now final answer is going to be a to the power of 3 over b to the power of 4. That is your final answer. I will be sending for you this on the group, so please just watch the group. You just need to copy it, and then tomorrow I will do another explanation. Are we clear? Alright, thank you grade 9. Have a lovely day. To get back to the work, grade 9, we are currently looking at there was a question now on the floor, and they asked us to look at question number 1.15. And we just going to recap on this law. This law says anything to the power of 0 is equals to 1. Alright, now we shouldn't get confused because there is actually invisible exponents sometimes. Like at the first one there, it was not the first one, but just the previous one. 7 has the exponent of 1. So the 7 is not to the power of 0. The 7 is to the power of 1. So therefore, it stays the same. So that one was 7 times with a to the power of 0, but a is now 1. And then it's 7 times 1, which equals to 7. Alright, now looking at that one, we have 3 times p to the power of 0 plus the whole bracket here is to the power of 0. You following? So what we can say here, 3 has the exponent of 1. So in essence, what is standing is 3, but p is to the power of 0. And anything we know to the power of 0 is equals to 1. So therefore, we can say that is 3 times with 1. And this whole thing is equals to 1. So 3 times 1, great stuff. Inam says it is 3 plus 1, which equals to 4. No? Alright, continuing now to law number 6. So law number 6 looks like this. Whenever we have a negative exponent, we want to write it as a positive exponent. So the law looks like this. If it's, for example, 8 to the power of negative 1, we're going to write it as 1 over 8. Alright, so let's look at the examples we are given there. Let's work through that. So that the first one is 2 to the power of negative 3. The first thing that I'm going to do here is I'm going to write it as 1 over 2 to the power of positive. When it goes down, it becomes positive 3. Now I know 2 to the power of 3 is actually 2 times 2 times 2. So it's 2 multiplied with himself 3 times. So therefore, what is 2 times himself? 2 times 2 is equals to 4. And another time, 4 times 2 is equals to 8. So that final answer is there. 1 over 8. Okay, and then we have there, the next one is x to the power of negative 4. X to the power of negative 4, once again we write it as a positive exponent, so it's just going to be 1 over x to the power of positive 4. Good, continuing there, we have a to the power of 3 at number 18. 1.18, a to the power of 3 times with b to the power of negative 4. Now look here, the a's exponent is positive or negative? Positive 3. Right? But the b's exponent is negative. So therefore that becomes a to the power of 3, which stays the same. And now it's actually multiplied with 1 over b to the power of 4. So now we're back at fractions, and a can be written as a to the power of 3 can be written as 1. We just multiply that. So our final answer is a to the power of 3 and b to the power of 4. Alright. Wait, can we start again? Can we start again? I'm not ready yet. Am I on the screen? How do we start again?